A circuit inputs.csv file has been found. So we have to go to this file, circuit inputs.csv. So this is the file. Here we have to enter different simulation parameters. So first we have to write name of the circuit file. So the default name is sample circuit.csv, but our name is basic circuit.csv. So we have to rename here. Be careful while writing this name, don't make any spelling mistake. Next, we have to give the time duration of simulation. So here I have the default value is 1 second. So let it be 1 second. Now time step of simulation. So it should be less than 10 microseconds for accuracy. So here I am giving the default is 1 microsecond. So let it be there. Next is the time step of data storage. This should be greater than the time step of simulation. So here it is 10 microseconds. So since it is greater than time step of simulation, which is 1 microsecond, so let it be 10 microseconds. Next is the name of the data storage file, that is circuit_output.dat. So if we want to rename this file, we can rename. Now we have to enter the control files. Control files are required if the circuit consists of switches, that is power electronics switches. Here this is a resisting circuit, so we don't need any control files. So we have to delete the files. These files are default. Now whether we want to split the output file. So our output file is circuit_output.dat. So if we want to split the output file, we should give here yes. So I am giving yes, and we have to specify at what time the splitting should take place. So I am giving here 0.5 seconds, so that there will be 2 output files. Since 1 second is the total time of simulation. So after filling this data, we can save this. Now we are done, so we can close the file and press Y and enter to continue. We have an alternate way to enter this detail, that is by going to the ice master folder. Here we have circuit inputs. This is also a CSV file. So we can open this file and we can enter here also. So this is another method. So we can fill here itself and we can close. Now we have done this, so we can proceed by pressing Y. Now a params.csv file is created for our circuit. So it will appear here. If it is not appearing here, we have to go to file and reload all from disk. Yes, we have the params file for our circuit. Now we can open this also. So this is the params file. So these resistors are from the circuit file. So we can open our circuit file. So this is our circuit. So the params file corresponding to this circuit is generated. So here default values are 0.001. For the parasitic resistors, as I told before, let it be 0.001 because it should not make any effect in our circuit. The other resistor values can be changed by from here itself. Let it be 100 ohms. Now we have other elements such as voltage source, ammeter and voltmeter. For voltage source, we can specify AC or DC. So I am here specifying a DC source. So I should give here 0, peak on, and frequency 0, and phase also 0. DC offset is where we have to specify the DC voltage. So I am giving here 200 volt. Next thing is positive polarity towards cell. So we have to look into the circuit. Here voltage source is at 812 or 12A. So the voltage should, the positive polarity should be at 11A. But here it is 13A. So we have to change to 11A. Now look at the meter. The polarity is 17R. Meter is here. So the positive polarity should be at 15R. So we have to change its value to 15R. Now look at the voltmeter. Here positive polarity should be 18N. But here it is 18P. So remove P and place N. So we have entered the params file. So these are parasitic resistors, paras 2, paras 3 and paras 1. All other resistors are the main elements of our circuit. So we can change the resistor values from here. Since we are trying to optimize this circuit for a particular output, now we are not changing the resistor values. So we have entered the parameters in the file. So after that we have to close the file and press OK. So here also we can enter it alternate way by clicking on the params file, which is a comma separated value. So we can also fill from here. I have filled it here. You can also fill from there also. So after that, save. Now we can proceed by pressing I. Now the simulation has started. During simulation, we will get a data like this. 1 equal to time, 2 equal to ammeter, REQ, 3 equal to voltmeter. This means after the simulation we will get a output file. Since we have specified a output file here, circuit output.dat, and we have specified that we have to split the file. So two output files will be generated. So one is circuit output1.dat and another is circuit output2.dat. So now the simulation is running. So now the simulation is over. So we can see that data is stored in circuit output.dat. So we have two output files, circuit output1.dat and 2. So we can open the file. This is the first file and this is the second file. Now you can see that the first column represents the time, second column represents the ammeter readings, and voltmeter readings is represented by the third column. You can see here 1 for time, 2 for ammeter, 3 for voltmeter. So the simulation is over.